All right. And I'm reading off this because, as you guys have seen already, we have a number of distinguished panelists tonight, and it's already been a great night hearing all their insights in the industry. And I want to make sure that there is plenty of credence to the careers and the input that they've had to the community. So first and foremost, we have Dr. Aaron Fisher, the Director of High Performance Computing for the Energy and Innovation Program at Lawrence Livermore National Lab. Dr. Fisher is an expert in simulation code development with a focus on multiphysics, computational fluid dynamics, and high-performance computing. He began his career at Sandia National Labs, contributing to the next-gen lithography alongside industry leaders in microprocessors. As director of HPC4EI initiative, Dr. Fisher facilitates partnerships between National Lab scientists and U.S. manufacturers to enhance energy and carbon efficiency in industrial processes, leveraging advanced computational science. So thank you for coming, Dr. Fisher. Dr. Kevin Newmeyer, a dear friend of mine and somebody who has been a great mentor for Rescale as we've kind of grown our company. So it's definitely great to have him up here tonight. Kevin is the acting director of the Department of Defense High Computing Modernization Program that sits under the Army Corps of Engineers. Dr. Newmeyer leads the DoD HPC program, advancing modeling and analytics to meet critical defense objectives. A retired U.S. Navy officer, a former international civil servant, he has extensive expertise in cybersecurity, civil military affairs, and national security. He is also a frequent commentator on these topics and serves as an adjunct professor in cybersecurity policy. Since taking leadership of HPC and in 2024, Dr. Newmeyer has overseen the program's $400 million annual budget supporting supercomputing ecosystems for multi-service science, technology, and engineering. He is a standing panelist on the ICANN Public Interest Commitment Dispute Resolution Panel and has received recognition for the contributions to policy development and international collaboration. An anecdote there is that he is actually rooting for Army in the beginning of December for that.
Oh, hell no.
Game.
Yeah, that's what I like to hear. That's good.
Next up, we have Cole Turner, who is a senior principal software engineer for HPC at Northrop Grumman. Cole Turner helps engineers tackle complex problems at Northrop Grumman by making the most of high-performance computing. With a focus on thermal fluid analysis and optimizing computational systems, he works on some of the most advanced aerospace and defense projects, including ballistic missiles programs. Before joining Northrop Grumman in 2021, Cole designed stealth nozzles for Pratt & Whitney and worked on innovative fluid dynamic solutions in the private sector. He holds a bachelor's degree in mechanical engineering from Georgia Tech and a master's degree in aerospace engineering from Purdue. Today, he uses his expertise to manage computational systems for engineering teams to ensure cutting-edge systems meet both technical and business goals. And then last but not least, Scott Grabow. Scott Grabow is the HPC technical expert and systems engineer for BAE Systems. Scott Grabow is a seasoned HPC systems engineer at BAE Systems, where he leads operational sustainment and multi-site support for high-performance environments. With over 30 years in the HPC industry, Scott contributed to systems featured on the top 500 supercomputing rankings since their inception in 1992, showcasing his expertise in system design, testing, and integration. Scott holds degrees in mechanical engineering and computer science, along with a master's in mechanical engineering with a focus on computational sciences. He developed innovative methods to improve high-speed interconnect, significantly improving metrics for large computing systems. Outside of work, he dedicates his time to preserving the history of computing as an archivist at the Charles Babbage Institute.
Babbage.
And so, we're not going to start yet because Matt got off easy. Matt got off easy on the first one without an icebreaker. So I'll give Matt an icebreaker. Matt, who's your favorite colleague at Rescale? There's a right or wrong answer.
Who's my favorite?
Yeah, it's hard. Go with the EA, it's always safe.
I would say they're all wrong answers.
Yeah. It's a trap.
All right. We all know the answer, so don't worry about it.
Yeah. Okay. All right. Well, thank you, gentlemen, for joining us. Let's get kicked off just like we did last time, just to get you to know a little better. Dr. Newmeyer, what's your favorite place of vacation?
I'd have to say on a sailing boat in the British Virgin Islands.
Just like a Navy man, I would expect nothing less.
I had a great time recently in the Yucatan Peninsula. I'd highly recommend it.
Oh, wow. Okay, great.
Yeah.
I probably have not been to my favorite place. I want to go to down in Peru to see Machu Picchu. However, my favorite place I've been to so far is my relaxation place, which is Boundary Waters Canoe Area up on the US-Canada border. No cell phones, no electricity, no interruptions.
That's fantastic. I went to Machu Picchu for my honeymoon, so I can give you notes. Go ahead, Cole.
I speak Spanish. I'll be your guide.
No, I'm a big alpine skier, so honestly, Jackson Hole is probably one of my favorite mountains. If I could just pick one, it would be that one.
All right, we have more to talk about than Cole also. Okay, Cole, I'm going to start back with you. I know that we might cover a little bit of ground, but given all the advancements in HPC and introduction of AI methods, what are some of the achievements in your organization or that you're most looking forward to implementing it at Northrop?
Yeah, so at Northrop, we're a really big organization. We have 4 business units and then over 60 sub-business units. And so our HPC, where I'm at in Utah, we support every business sector. And so we have a lot of different problems that we try to solve. And so we're looking at, I think we touched on it earlier, about a lot of the surrogate modeling and the AI ML capabilities. At Northrop, we're very nascent in this field. So we're still looking at ways to implement ML models primarily through GPUs. So we're looking at that capability. I'm excited about it. We had a meeting with Rescale at Supercomputing talking about this capability with some of our key stakeholders at Northrop. So, but yeah, it'll just be similar to what we talked, just creating surrogate models, running it on massive amounts of data, training it up, and then testing it and seeing what that predicts.
Right.
I normally don't work in the AI realm at all. I'm traditional HPC. I've been there since, 92. However, I've had recently, because of my position, had to start interfacing with people that are doing AI models and getting people to make the step from, I'll say, the traditional world to the next level of parallelism is usually the first part of where we're running into, I'll say, the convergence. People are used to doing what they've always been doing. Do people right now have an AI model that they can run thousands, run their simulations through? No, they're still doing it on laptops and they haven't learned how to scale it yet. With that though, we got done submitting to a government customer some projects to how can we take the AI model and get the data in quickly, get it computed, avoid doing the network traffic, and get the data back out. And that was actually a very fun, I'll say, thought design, because all of a sudden you're taking the entire HPC system, breaking it apart and trying to get memory and processing power all at the same location to avoid the power that you're going to have to use to transmit the data, which is what our systems, right now are based upon.
Dr. Fisher.
Yeah, so in Livermore, we're jumping into the AI game as well. As a classical modeling and simulation expert, I'm trying really hard not to have AI eat our entire lunch. So really, we're deep in the game of surrogate modeling, as was mentioned before. And I like to look at that. I actually kind of turn that upside down. The AI modelers want to come in and sort of model our problems. And I say, well, look, you need lots of data. Our mod sim products are the things that give that can be a huge data magnifier for you. You have a little bit of data about your system, and you can use that to validate a physical model, and then you can use that physical model to generate all the data you need for a surrogate model. So we've had a lot of success doing that over at Lawrence Livermore. And the other thing we've been getting pretty deeply into recently is differentiable computing, which is sort of a game changer when it comes to optimization on some of these ModSim systems. This might be a little adjacent to some of the AI technology. But,
Can you talk a little bit more about that?
Yeah, so differential computing is something that we're using to take our modeling and simulation codes and actually provide derivatives of the codes with respect to a bunch of variables automatically using compiler technology. Because you have these derivatives, it's much easier to pass these things through an optimization system, because the optimization system has a good sense of what direction to step out for its sort of next step in its optimization. So this is allowing us, this is really speeding things up, like topology and shape optimization in a lot of our industrial projects, and we're sort of diving deeper and deeper into this right now.
What are the undergirding technology capabilities that are helping you do that?
Yeah, so some of this, the LLVM compiler system is sort of an undergirding technology that lets people sort of get at the guts of the codes themselves when they're being passed through the compilers. And there are people that are being able to take that and be setting that up so that it can provide those derivatives for us. The other undergirding technologies are just a really solid understanding of course, the mathematics and the numerics of these systems as well. So this is these are things that are being developed right now. We're probably going to be seeing a lot of this in the next 3 or 4 years.
Right.
Yeah.
For us in the Department of Defense, we're very good at physics-based models. We have excellent software teams that have developed tools to design aircraft, design ships, and develop those and answer those basic physics questions. The challenge is, I work in a political environment. Our senior leadership are politicians and business majors, and not necessarily scientists. Generals are great. Some of them actually can think. Some of them are really good at leading troops. So you have to work through that, and you have to be able to develop products that you can rapidly change. So we have to be able to take the physics model, so we know the physics and what the weapon system is going to do, and then abstract that into, okay, now I have hundreds of planes. We're fighting a war. I can't run a physics-based model on 300 aircraft interacting with each other. So we have to go to the surrogates, as the others have said. And then so we do the surrogate models, we get those down to run, and we can answer the questions of force on force and those types of things. And then we present that to the flag staff, and they go, yeah, but what if? Okay, so I can't go back through hundreds of hours of computation. We have to be able to rapidly come back with an answer. Okay, so if I add another wing of aircraft, or I add another division of soldiers, how does that change the battle space? So we have to be able to use surrogate modeling and to move ourselves up the modeling and simulation pyramid. So we're moving now more into answering questions in campaign analysis that we have the tools built for traditional, physics-based, building the airplane and making it work. So that's where we're heading in the next couple of years, to try to be able to answer those questions, because, lo and behold, the peace dividend went away, and we're now in a near-peer competitor environment, so we have to be able to adjust to that and change our business practices within the organization. So that's where we're moving. We see cloud as an opportunity to get some technologies in that may be faster than the god-awful government procurement system that takes forever. So we have to be able to react faster than we have in the past. So that's where we see opportunities and where our future probably is heading in many respects.
Dr. Fisher, I'll start with you in this next one. So we talked about how, and you actually just mentioned about how AI can suck a little bit of the air out of the room sometimes, and there's a lot of other stuff to do there. what are the practical strategic approaches you're using to navigate transformative capabilities, like the hype versus reality, and where you need to be spending your time innovating?
Yeah, at my laboratory, so the way we've handled that is we've pulled this sort of array of AI technologies, these LLMs and generative AI technologies, and of course the surrogate modeling and stuff that we have people playing, and we've pulled them in so that all of our researchers can play with them, and we're letting them just try things out. So we've got a pretty large program where people are trying things out and kind of recording what they do. So we're just throwing all of our researchers at it to see where we can actually use this. Some people are doing this a lot more excitedly than others. Some of us are curmudgeons, trying to live our mod sim dreams for the rest of our lives. But and we're finding use cases that are useful for us and finding things that aren't particularly useful for us. We've only just sort of started this process maybe 3 months ago, but I think that's, at least organizationally, I think that's a pretty good approach, right?
What's the governance model that you're using to help surface? Are you asking people to actually do lab-wide presentations on? You have a committee. Sometimes the very practical implementation of some of these things are actually organizationally sometimes the hardest parts to navigate.
Yeah. So it's bubbling up more like a university, right? So the things that are working, people get excited about, and then they sign up to give presentations, and people that are interested in it show up. It's very much not a top-down approach. They kind of just provided the tools to us and said, "Hey, everybody, try this out." Which is when you've got a couple of thousand PhD researchers, it's a pretty good approach.
Dr. Newmeyer,
We have to deal with
this must be very hard.
We have to deal with the silos of excellence problem in the Department of Defense. There is the Chief Digital Analytics Office, who's supposed to be over the AI stuff, but they don't actually have any computers. I've got the computers. So, a lot of it is outreach, working across the department, trying to explain to some people what we can do with our systems, trying to figure out what we need to buy in our next round of procurements. So there's lots of different things working on. We've got AI projects where we're trying to use our supercomputers to train and retrain models that we need necessarily to be developed somewhere else. But we're looking at things like learning as the combat's going on in Ukraine. They're constantly having to innovate, take lessons learned from the edge in the combat world, and bring that back, retrain the model, and then redeploy it. So we see some work, certainly in that area. We are, by definition, our research and development side of the Department of Defense. So nothing in my computers is directly in the line of somebody pulling a trigger, but we have to be able to feed those trigger pullers the latest and best information. So we're trying to develop the technologies, the processes, the data, decision making to be able to feed that stuff forward and break down some of these silos and really expand what the role of AI is guiding weapons development going forward.
Cool. I'd be interested in that.
Yeah, so it's tough because, we're right now a very highly CPU-based computational organization. We don't really do much with GPUs. We're trying to build a system that's flexible enough to adapt with the growing need. But I guess if you want to zoom out, honestly, our engineering base isn't really looking to use machine learning and AI to develop their models. We have, like I said, so many business units we support, and the analysis that goes into some of these, ton of CFD, a lot of structural. They're not really looking to change the game, I would say. So it's almost like with NVIDIA changing the game, with CUDA using GPUs, it's the cart before the horse for us. And we're really trying to build a system that will adapt to the changing engineering needs as engineers start to use those models, but we're not seeing the demand signal right now for that. I think using Rescale, right, it gives us a flexible platform to do that. But honestly, where we're currently at is just a very CPU-driven organization. And so that's where we're focused at.
Scott, what are you saying?
Kevin and Aaron have been around probably long enough. They remember going through this in 1993, where all of a sudden you went from a vector processor that was a workhorse that could do things to a commodity processor that was inefficient, but it was cheap. You could build a Beowulf cluster for, at that point in time, I'll say a couple $1,000, remembering that the average PC cost was $1,000. The CPUs were not capable of doing anything. And over time, what you see is the things that worked on those early MPPs, which are now our bread and butter systems, became more like the thoroughbred. AVX 512 is a direct lineage of the old vector processor. Why was the vector processor created? It was created because it could do a computation quickly, you could pipeline it, you didn't have to worry about transfers, and I see the same situation happening right now. AIML has an advantage. Right now, what it's forcing people to do really is look at their model, or looking at how much precision do they need. Do they need FP64? If you're doing a weather forecast, yes. But with AIML right now, you can take and start producing a global model of the world that can handle a good part of the global prediction. You can feed in your local information or your regional information and get the answer out in seconds, rather than all of a sudden you are waiting for your weather forecast. Most people don't realize is your weather forecast is produced every 4 hours. That is usually your next 48 hours. Every 6 hours is 24, and your long-term forecast of 14 days is usually taking about 36 hours. With AIML, you can start to produce that, refine it, and give you better resolution down to, hey, I'm at this geographical location, and you can get that. It's going to be a mirroring of the two. The problem I see right now is AIML, as you talked about in the earlier one, is sucking so much of the technology and everything else that the traditional math and science-based computations are starting to, what do you mean you can't do this? You used to with this previous generation. And the generations are moving so fast. We're talking, 18 months typically for a new system to come out. Every year at SC, new gear is coming out, and the question is, we can't afford to continue to buy the new big systems every year. Look at how long it took to build El Capitan. Look at how long it took Frontier. Those projects started in 2013 as R&D projects. They are massive in scale and in computational capability. We're going to have to find a solution between the two.
Going to pivot a little bit to security. I'm going to start with you. And that is, so traditionally HPC professionals just completely look past security. It really wasn't until, so let me finish the state, let me finish the opener of this. NIST, in February 2024, I believe, published its first, published document. I know there's a draft back in 2016. I think it was 823 about HPC security. That was kind of the first time that NIST has dipped their toes into this concept of looking at enterprise architecture security for on-prem, but it's typically been something that hasn't been front of mind for HPC professionals. How is that changing, in your opinion? And especially as an adjunct professor for cybersecurity, I think you're a great person to walk us through this.
One of the things with the DoD high performance computing program is we have our own network, the DREN, the Defense Research Engineering Network. We are considered part of the Department of Defense Information Network. So all of my cybersecurity requirements flow down to me through Cybercom and the National Security Agency. So I have to meet all the same requirements that the rest of DoD has as far as protection. One of the challenges we have is, as you pointed out, most of DoD enterprise systems or enterprise architecture. It's all Windows and Microsoft Outlook and those kind of things. You come to we have to get our software accredited. Well, initially there weren't any tools that were accredited a Linux-based system. They didn't exist within the DoD. We were fortunate to be able to be involved with NIST and help them. We had some of our cybersecurity experts work with NIST to develop that HPC standard. So they were key to writing that. We had developed some of our own tools to monitor the networks and be able to see what was going on. So we have to blend those two, meet the requirements to secure the data and and validate the integrity of our systems. So we had to develop our own tools and develop our own expertise. And we monitor our systems and 24/7. I have CSSPs that support me at different classification levels. So we are doing that. We just had to figure out how to do it in an HPC environment. Fortunately, I have some people that have been in the program for longer than I have that grew up with HPC, so they understand the complexities. As a research network, we can get away with a little bit more, but we still have to be secure because we're constantly facing phishing attempts to try to get our software or try to get inside of our networks. So we know that's happening, and we tens of thousands of hits a day are coming against our environment. So we're dealing with all that stuff the same as any other network would these days. But if you develop the tools for HPC, when you bring that mindset to the game, it made us easier for us to then go and explain that to NIST and to NSA that we really are secure. We're not the wild, wild west.
So, Dr. Fisher, you don't have the luxury or the privilege of sitting behind DREN as a national lab. And so how do you think, how's your organization thinking about this problem?
So I think you're asking the wrong two people first, because Lawrence Livermore is a national security lab, and we also have our own classified air-gapped network that El Capitan sits on, right? None of you get to touch it, right? And probably somewhere around 90% of our computing sits on our classified, or we call the high side computing. We do still have security concerns there, right? We do have to send data over there. We got to send software over there, we've got processes for examining the stuff we're sending over there and stuff we're sending back. But just like the DoD folks, we also have networks that aren't on the high side too, right? And we have to protect those as well. And so that's sort of where the sort of normal security posture stuff has to exist. And we've got cybersecurity teams that are fielding thousands of attacks a day. We've got layers of network security all over the place, right? There's a lot of access control everywhere. We also have physical access control to our site. Guards with guns will not let you in. So we take security very, very seriously at Lawrence Livermore. So I'm not sure. Yeah,
how does security impact? How does it impact technology decisions that your organizations are able to make?
Yeah. Well, I think first and foremost is starting with the security mindset. Working as a defense contractor, pretty much everything has to be controlled. Very similar to you, Aaron. I think most of our computes, it's air-gapped systems. We do have a large amount of compute, that is still on the Gov cloud, has to be on the Gov cloud or the FedRAMP on the cloud. So it's just, keeping that the focus and just understanding your classification of your data that you can transfer over the internet. Similar, we have cyber teams, It's kind of a pain, getting anything accomplished in less than a month is a win, I would say, just from all the paperwork you got to fill out. So just part of the deal.
Do you want to add anything to this, guys?
What I can add is, I'll jump off of where Kevin and Aaron have, is what most people don't realize for the Department of Defense or a defense industrial base, which is what our two companies are, is we are stuck in a situation where we have to comply. We're also in a situation where, like Kevin was talking about earlier at the beginning, he has people that don't understand. And HPC is a hard system to understand. I will get an email once a week for every system, and it will start off with, do you run Microsoft Windows? Do you run this? Do you run that? No, we don't. We run Linux. And we are left with having to produce a report saying, no, this software is not present. No, this software is not present. And actually for us, one of the things we've been wanting to do is work on processes such that we can take the inventory and have it such that when we get that report, it's already been filtered for us. They have been given the information because we have been told, and we have told to them, this is the operating system, this is the version, this is how many end nodes, this is what's going on, this is the capabilities. Right now, though, the security framework is not set up to do that. It is a blanket checkbox of CVEs, common vulnerability exploitations. The industry is now having to go to KVEs, known vulnerabilities that have been exploited. Why? We are dealing with, I think it was last year, I have the number wrong, I know that, I'll preface it with that, but the number was amazing. It was like 250,000 vulnerabilities found in the software stacks of software that's being used. That is not taking into account every homegrown package that a person makes or anything else. That is across Windows, Linux, whether it be Red Hat, SUSE, Debian, Ubuntu, things like that. We can't keep up producing a checkbox for every question. It is going to be insurmountable. It is right now, which is why the industry is moving to KVEs. We will still see the CVEs and hopefully fix them. But when you're dealing with a software stack on an HPC that could have, I'm trying to remember what the Red Hat distribution is. It's amazing. You install a Red Hat package on a PC, you get an audio driver, graphics card you still need. Do we need a Wi-Fi driver for a unique Broadcom chip? No. But those are the things that we all have to see and deal with on the security side. We're going to be buried in paperwork.
And not necessarily be any more secure.
We'll actually be less secure because the paperwork is preventing us from taking a look at the systems and seeing something looks phenomenal on the system, which is where AI can help us out.
Yeah. And that's also where HPC can help. But we have developed some internal programs and working with some technologies to actually look and see, okay, what is anomalous? What doesn't look right? And then use the HPC to rapidly process the data and the logs and those things. Okay, so what's wrong here? And then you can go investigate.
I remember 2014, that was, kind of the holy grail of where parts of the Department of Defense was saying, look, we need to be able to, in real time, look at something and say, this is anomalous. Why is this happening? We're not there yet. Why? Because AI/ML is looking at other problems. We need to take the advantage of AI/ML and push it into security.
Dr. Newmeyer, I'm going to jump to you next. So the future of the HPC professional. You got HPC software, traditional CPUs, adding GPUs, adding cloud, adding security considerations. What does the future of the profession look like from your perspective? How do you make sure you have the right talent? What does talent development look like? Running an organization that focuses on this. What are your thoughts?
That's probably our biggest challenge. I'm fortunate I have an excellent team that I work with. One of the challenges I have is they're all getting to be closer to my age. How do we bring in people at the younger age groups and then bring them up in the system so they actually understand HPC as opposed to something else? We have internship programs and all that, but it's what keeps me up at night really is who's going to replace me and my senior staff here in the next couple of years. How do you develop those people? We look at internships. I'm trying to cross-fertilize people. And one of the advantages of being, when I was a military officer, is I had jobs in engineering, I had jobs in operations. I learned everything about the ship, how it worked, and how to employ it as a system. So how do you develop that in a new person? That becomes a challenge. You have to educate broadly. You can't just focus solely in one in one field. I was fortunate as a junior officer to be selected for a program to study overseas, but the ultimate goal was to make me a better leader and officer because I understood different cultures and different things. I was able to bring those skills back into my engineering world so that, yes, I can think differently. I mean, my graduate degrees are not in the sciences, but I had a firm scientific engineering base that I could then bring in these other skills and start asking the questions of people that reported to me, why? You know, nothing scared a gas turbine engineer more than a nuclear engineer asking him a question. You know, the mythology of Rickover persisted throughout the Navy. I think you should educate people broadly, let them try different things, and be not afraid to fail. You know, people are going to make mistakes. You can't kill the messenger who brings you the bad news. You have to be able to, you know, accept that and go, okay, how do we learn from this and move forward? You know, and find a diverse environment. You know, bring people with different skill sets to bear. That's the key to being successful, I think, in the long term, in the HPC space or really in any other scientific and engineering endeavors. You know, I had lots of engineers that came to work for me in nuclear power that couldn't write an evaluation. It was pretty scary, so we had to teach them how to write in standard English. But if you cross-train your people, they'll adapt and excel in most cases. Nobody wants to really do a bad job.
Dr. Fisher, how do you think about the future of HPC professional?
Yeah, so I look at it a little differently. I don't think of a particular person who is an HPC professional, just like we have sort of a software stack that we run things on. We have an engineering stack that we go to solve these problems. No one person really solves all the pieces of the problem. I think cross-training is really, really important, but I think different people are going to take on sort of different pieces of this. They're going to be people that are numerical modeling folks that are going to take on, they're going to be focused on the math. They're going to be people that are at the computer science level putting libraries together to solve problems. There's going to be engineers that are running codes that those people wrote in order to solve physics problems. There's going to be people leading those people that are using those simulations to understand the systems that they're trying to understand and get insights and move companies in different directions based on those insights, right? Even under, below the lower level, there's people in the computer science realm that are working. There's people that are running the clusters. It's an entire ecosystem. But I think you're right. I think once you have someone who has focused, trained on a piece of this, getting them to talk to people across this entire ecosystem is extremely important. It really takes the entire team to move forward, and if no one's talking to each other, you get this setup where you have these silos of excellence and no one ever and you can't get anything done. So that's sort of how I see it as an entire ecosystem. Scott?
I'm in a world where, we need to do things, smarter, better, faster. I take the agile approach to selecting people. I don't select them for their knowledge. I have seen tons of people that can, listen and recite sections of a book, and great, do you understand it? No, they can't work their way out of a paperback. I look for problem solvers. Why? Problem solvers inherently look for problems. What do we have to deal with? What do we have to solve? Why do we have to solve it? How can we, find a solution or two or three? Because we are going to have to go talk to somebody else to get them to understand the situation. With that, though, you then have people, much like what Aaron was saying, you have a person that prefers to do security. You have a person that prefers to do networking. You have a person that prefers to do numerical work. You have a manager. Nobody's going to know everything. And getting those people to communicate is the hardest part. Why? Because everybody thinks like themselves. No, you have to write to your audience. And in trying to talk to people and get them to understand it, that's what I look for. People that are driven to understand and dive into a problem. Why? Those people will become people that will become well-rounded, much like what Aaron is looking for, and be able to communicate and help other people, like what Dr. Newmeyer is talking about. You know, engineers, I will say, fit into a common model, and I'll say it's also wrong. You know, we're quiet. We don't like to put ourselves out there. We like to do things safe. I have watched engineers do some of the stupidest things in their life, you know, trying to blow off steam. They know it's stupid, but with it, they come out of the experience with a failure, you know, something that went wrong. They then dive into why did it go wrong? And from that, it gives them additional insight. Those are the people I look for, people that are driven, you know, deep dive and try to find problems and are willing to share their experiences. I mean, we've all been through college. How many times, you know, are you in your field because you chose your field, or are you in your field because you found a professor, a TA, or somebody else that got you interested in this?
Cole, you have the final word on this topic.
Oh man, I don't know, how do I close it? I could talk to my personal experience and how I got into HPC. You know, I was a CFD engineer for 9 years and then moved into IT. So it was just my passion for improving my own models, and that got me into it. But getting into it, honestly, like at Northrop, there's these silos that we've developed, like, no, this is my system, these are my users, don't get on my system. That honestly, the cloud, it presents a really intriguing opportunity in the HPC space. If only classified cloud were a thing, if we could all jump on fences. But for the unclassified space, honestly, it's a paradigm shift in the way that you think about managing your HPC. And so when it comes to like, what does your traditional HPC engineer look like? You know, I don't know, because it's, you know, resources like Rescale or even just going straight through a mainstream provider, it's like you don't really have to be a computer guy. You know, I'm not really a computer, I'm an aerospace guy that knows computers, but it gives you access to the instance and then, you know, the benchmarking profiles, and then the way we looked at it, our systems is like, oh, that's a Swiss Army knife, right? Like we have one computer system that handles 40 different workloads, right? And so it's great. But Rescale, or the cloud, it's a laser, right? You can pick and fine choose, point, you know, your systems, and I didn't have to do any of the hardware setup. I don't have to worry about the cooling, you know? So when it comes to being an HPC engineer, it's really more about being a business economics, right? What's the most efficient way to go from A to B? Is it cost? Is it performance? And that's kind of the space I'm exploring, honestly. We still have on-prem systems, and that's cool and stuff. And I think a hybrid, you can't really get rid of it on-prem, but I don't know, the cloud's changing the game from my perspective, getting rid of these silos.
Well, we'll close it with a fun question. Same one we did for the last panel. Book, movie, or podcast that you'd recommend? Dr. Newmeyer, we'll start with you.
Well, the fact that the only game of the season that actually matters is coming up here in a couple of weeks, I'll go with a Civil War. The story of the Army-Navy game, 1996. Which the wrong team won, but I actually went to the game.
Was it good?
Yeah.
It was an excellent game.
Good.
He should have kicked the field goal and not gone for the touchdown.
Caves of Steel by Isaac Asimov. It's a great tale of how the technologies that we invent and use affect us.
So Kids of Steel.
Caves of Steel.
Caves of Steel.
Yeah.
Thank you for clarification.
Yeah.
I can't remember the name of the book. And the reason being is it's about the Apollo 11 lunar module and the Apollo flight computers. There's a wealth of historical computing information. I was at the National Air and Space Museum a little while ago, and I had a coworker, and he was like, what's all of that stuff in the ring there between the stages? And I started going into details, and he's just looking at me like, why would you want to read that? Because right now, this smartwatch right now has more sensors and more computing power than what man landed on the moon in 1969. That's how much we've advanced, and that's also how much we've regressed.
That was a very deep statement.
Yeah, I've been on this IT journey for a little bit, and honestly, one of my biggest resources has just been the Acquired podcast. And
It's a good one.
yeah, so executives love it.
Yeah.
So there's great stories about NVIDIA on there and stuff like that. From a guy who didn't grow up in the silicone world, has helped me get a lot of the history of all these companies that have merged, and this company used to be that company, and vice versa. So, yep.
Okay. That's it for our panel. Let's give everybody a round of applause.